Hi guys, now I want us to do June 2012. Okay, so this one is about quadratic function. Okay, so we're going to calculate many things here. First of all, we're going to calculate what we call we're going to talk about what we call a value. That's number one. Number two, we're going to talk about turning point. So what's the other name for turning point? It's vertex. Okay, they can say calculate the vertex or turning point. Okay, three, we're going to talk about the interception. Okay, fourth, we're going to talk about the discriminant. Discriminant. Okay, fifth, we're going to talk about, after discriminant, we're going to talk about x-interception, discriminant. We're going to talk about the c value. Okay, so now this is our question. They've given us the quadratic function of so the formula for quadratic function is y is equals to ax squared, okay, plus bx plus c. And then in our situation, they've given us the quadratic function of y minus x squared. So it's going to be y is equals to minus x squared, okay, minus 4x plus 5. So what does this mean? This means that ABC, our a will be what? Remember, it's ax squared, so it means our a will be invisible -1, so our a will be -1, our b will be -4, and our c will be 5. So it's very important to listen to this one actually, because this will help you to apply this information to a lot of questions actually. Okay, so what you're going to do here, we're not basically going to answer only these questions, so we're gonna answer a lot of questions that are likely to come regarding to the quadratic function. Okay, so now let's talk about the a value. So we're answering number one now. A value. So about a value, we have two things. Okay, we have two things which we have to look at. We have a situation where a is greater than 0, and we have a situation where a is less than 0. So what kind of a graph do we have when a is greater than 0? The graph will open upwards like this, and then so when a is greater than 0, we have what we call a minimum point. Okay, so the minimum point is here at the bottom, at the turning point here. But if a is less than 0, we have a maximum point, so it means your graph will be like this. So this one is your maximum point. Okay, so in our situation, our a is -1, so a is equals to -1, so it means -1, a is what? Is less than 0. So we expect a graph that has a maximum turning point. So how many graphs has a maximum turning point? It's only graph number 4 and graph number 2. Graph number 2 and number 4 has a maximum turning point. So we have this maximum turning point for the fact that our a is negative what? It's -1. So since our a is -1, So we have a maximum turning point. So now we are done with A, and then we now know that the correct option is gonna be at 2 and 4, since they all has a maximum turning point. So now let's talk about the turning point where actually our graph should turn at. Okay, is it that our graph will turn at negative 2x along the x-axis, or will turn at positive 2 along the x-axis? We need to calculate that one. Okay, so I'm gonna take the new sheet here and write. How do you calculate the turning point? So to calculate the turning point, guys, you need to know this. We're calculating the value of x and the value of y. Okay, so let's calculate the turning point. So number 2, turning point, turning point or vertex. So here's the formula. The formula is also provided behind the question paper, guys. If you see a formula saying xm is equals to minus b over 2a, that is the formula for turning point when you're calculating the value for what? For x. So now remember, in our situation, we're dealing with this graph of y is equals to negative x squared minus 4x plus 5. Okay, so our a in this case is negative 1, our b is negative 4, and our c is equals to 5. So now you need to substitute here. So you will be like x is equals to your b is negative 4, so it's going to be minus 4 over 2 times a. Your a is negative 1, so it's going to be 2 times negative 1. So now your x at turning point will be how much? Negative and negative will give you positive 4, and then over negative 2. So your x at turning point will be what? Will be negative 2. So the correct graph here of x at turning point where x is negative 2 is option number 4. So option number 4, it will be the correct graph. But anyway, like I said, I'm gonna use this question to answer several questions. Okay, so I'm not gonna end here. I'll say at turning point x is 2. What about y? So I'll write this equation. Y is equals to negative x squared minus 4x plus 5. So what does this mean? It means wherever there is x, I'll substitute using negative 2, because x is what? It's negative 2. So it's like it's negative 2 squared minus 4x plus 5. And so here I'm not supposed to say 4x. It's like minus 4 times what? Times negative 2 again, because our x is negative 2. So now y is equals to it's gonna be y is equals to negative 4 plus 8. Negative 4 times negative 2 to give us plus 8 plus 5. So now y is equals to 8 plus 5 is 13. 13 minus 4. 13 minus 4 is 9. So y is 9. Okay. So at turning point, you need to write these coordinates very well. Remember, the first coordinate is for x and the second is for y. At turning point, our graph x is 2 and y is what? And y is 9. So if you look at graph number 4 here, x is at 2, at negative 2 here, at turning point. You see where it's turning? And y is at 9 because it's 8, 10. So it means in the middle, it's 9. So at turning point, x is at 2 because along the x-axis, x is at 2. And then at turning point y, along the y-axis, y is at 9. So graph number 4 is correct. But anyway, let's proceed with this information. Let's talk about the x-interception. Do you see on graph number 4, we have the x-interception where it's intercepting x at 1 and x is being intercepted at what? at -5 again. So what does this mean? This means that we need to calculate and verify if whether the graph is going to intercept at -5 and +1. So we use the quadratic formula for calculating the x-interception. So how do you do the quadratic formula? You say x is equals to minus b plus minus the square root of b squared minus 4ac, and all of them divided by 2a. So you're gonna come and say, from your information, the value of a is equals to -1, the value of b is equals to -4, and the value of c is equals to 5. So now you come and substitute here with your value. So it means x will be equals to minus b, so it's going to be minus 4, close bracket, plus minus square root of b squared, so it's going to be minus 4 squared minus 4 times a is minus 1, c is +5, okay, all divided by 2a, so it's all divided by 2 times 1, okay. So this is how we do it. Okay, so it's gonna be x is equals to negative times negative is positive, plus minus square root of, okay, so these variables inside, they will give you positive 16 here, and then -4 times -1 is +4. So 4 times 5 is going to be 16 plus 20. All over 2. So x will be equals to 4 plus or minus square root of 36 all divided by 2. So x will be equals to square root of 36 in your calculator, it's 6, so it's gonna be 4 plus 6 over 2, or 4 minus 6 over 2. You see now I splitted plus or minus, you see how it goes. And then now x, it will be equals to 4 plus 6 is 10. 10 divided by 2 is 5. So x is equals to 5, or 4 minus 6 is -2. -2 divided by 2 is -1. So it means the x-interception, they will be found where x is what? Where x is 5 or -1. So let's see. In graph number 4, let's see here in graph number 4, the x-interception, you see where the graph is intercepting x is 1 here. So I have a problem here. Let me rectify very fast, guys. Our a is -1. I didn't put -1. I'm so sorry, guys. I'm so sorry. So it means here is supposed to be -2, and here is supposed to be -2, and then here is supposed to be -2. So now what's going to happen is that 4 plus 6 is going to be 10. 10 divided by -2 is going to be -5, okay? And then 4 minus 6 is going to be -2. -2 divided by -2 is going to be +1. So the 1 will be positive. So now when you come here, along the x-axis, x is intercepting at +1 and -5. So this is how you calculate the x-interception using the quadratic function. So this is how you do everything. So you can screenshot this information to enable you for practicing, okay? So let's proceed with the value for c. Remember the value for c, I said something about the value for c. I remember saying something about the value for c. Let's calculate c value. So c value, we're referring to this value, and our c value is 5. Do you see? Our c value is 5. So C value refers to what? Let me find another copy here. So C value is equals to what? Refers to Y interception. Okay, so C value refers to the Y interception. So this is the C value, refers to Y interception. So now that the C value is equals to 5, you see C is equals to 5, so it means Y is going to intercept at what? At 5. So Y intercept at what? At 5. So now we can put it in this way. So it means along the y-axis, x will be at 0 and y will be intercepting at 5. Remember, the first variable is for x and the second is for y. So the C value determines the y interception. So it means our x will be at 0 when y is intercepting at 5. So if you look at this graph here, number 4, the parabola or the curve is moving and is curving here at the turning point. Do you see it's intercepting along the y-axis in the middle of 4 and 6? So it means it's intercepting here at 5. So where y is 5, that's where we are having the interception. So it means where it's intercepting, y is at 5, and along this line, x is here at 0. So that's why I'm saying y is 5 and x is what? It's 0. So y interception is at 5, and along that line x is at 0 when y is at 5. So one more thing, we need to know how to calculate the discriminant, guys. Okay. So now let's do the discriminant. Okay, how do we calculate the discriminant? So this is a very complex and interesting part. Okay, so a discriminant has a formula. So I'm gonna give you my formula here. D is equals to b squared minus 4ac. So this is how you calculate. So if you have to look at this formula, I took it inside the square root of a quadratic formula, b squared minus 4ac. So that's why I took this formula. So now remember, your a value is minus 1, your b is equals to negative 4, and your c is equals to 5. So to calculate the discriminant, so you will say d is equals to minus 4, because the b value is minus 4 to the power of 2 minus 4 times negative 1 times c, which is 5. So your d will be equals to 16 plus 20. So the value of d will be equals to 36. So your discriminant is 36, so it doesn't end there. I'm gonna draw a small table for you guys here. So you need to know this table, guys. Please know this table. So d is equals to 36. So let's talk now. If the value of discriminant is greater than 0, and if the value of discriminant is equals to 0, and if the value of discriminant is less than 0. So if the value of discriminant is greater than 0, what do we have? So if the value of discriminant is greater than 0, we have two separate x intercept. So this is what happens in our situation. Our d is 36, and 36 obviously is greater than 0. So what did we have? We had two separate x intercept, and our x intercept is at x negative 5 and x what? x1. Okay, like what we calculated here. This is our two separate x intercept. X is at negative 5 and x is at what? At positive 1. So you can even write them as coordinates like this. X is at negative 5 when y is at 0, and x is at +1 while y is at 0. So this is our x-intercepts. You can also write them like this, okay? So now the value of our discriminant is greater than 0, so we're gonna have two separate x-intercepts, and we calculated the x-intercepts and we found that x is at -5 and 1. So when d is equals to 0, what do you have? You only have one x-intercept, so we have one x-intercept. Okay, we have only one x-intercept. So how can someone see one x-intercept? Let me find you a graph here. This is your x-axis. So if you have one x-intercept, it means your graph must just cut the x-axis once like this. So this is your one x-intercept, okay? Or sometimes it can cut your graph like this. So this is one x-intercept here. So remember, I'm using freehand writing, so my graphs are not looking very good, but that's what I'm trying to say. So this is one x-intercept because the value of d of discriminant is equals to 0. We have one x-intercept. So if d is equals to 0, we have one x-intercept. So this is the one x-intercept. So the graph will be turning at the what? At the x-axis. So it's tangent with the x-axis. It's touching the x-axis, okay? Once. So we also have the value of d less than 0 when discriminant is less than 0. So it means when discriminant is less than 0, it's like d is equals to -36 or d is equals to -3. So any negative number is less than 0. So when discriminant is less than 0, we have no x-intercept. So we have no x-intercepts. That's how it operates. We have no x-intercepts, okay? But fortunately, our d is greater than 0, so it means we definitely have the x-intercept. So what's going to happen here? We have no x-intercept. So it means if you have to draw your graph, let's have a look at the graph that has no x-intercept. This is your x-axis. So if the graph has no x-intercept, it means it must play under the x line. Oh, this is very bad. Let me draw another one, okay? So the graph must play below the x-axis. So as you can see, this graph is not touching x here. It's just playing below x. Or it can either play above x. This is the x-axis. Let me draw another one. Along the x-axis, it can also play above x. I'm so bad in drawing. Okay, let me draw here. So it can play above x like this. So you see this graph didn't touch x, but this one is producing a minimum point to show that a is greater than 0 and d, because it's not touching, so it means d is less than what? Is less than 0. Okay, this one is not touching, but it has a maximum turning point. It means a is less than 0. For the fact that it's not touching, so it means the discriminant is also less than 0. Okay, so please, you need to practice this stuff, guys. You need to practice this stuff. So they like giving us this kind of questions. I don't know what's happening with my camera here. Okay, thank you. So we need to practice this stuff, guys. We need to practice. So that's all what I have, guys. All the best.